In this video, we will use the hot water model to estimate the savings for flow restrictors on faucets in a bathroom. We'll start by going to energy. We will need to add two components here. We will need to add a heating system, which is the hot water heater. Then we will need to add an end use, which is hot water. I'll begin with the equipment, the heating equipment being a hot water heater, and I'm going to select water heater, and I'm going to assign the hot water heater to electricity as it's an electric hot water heater. I will then use an efficiency of 100%, which is what we assume for an electric hot water heater. That would be neglecting any minor standby losses within the building envelope. As I'm not changing the water heater, I'm going to copy base to propose to ensure that I have the same hot water heater in both situations. Next, I will use the energy drop down, select hot water, and now I have the input template for essentially calculating a number of things around hot water use in a facility. I'm going to be using a load type calculator in this example, and that will allow me to estimate the load for a given type of building. The type of building that we're going to be estimating the hot water use for would be an office. We're going to tell RedScreen that we have 100 people in our office and that it's 100% occupied. RedScreen at that point will estimate for me that each person will contribute 3.8 liters per day to hot water consumption for a total of 380 liters. I can use that value or I can choose a different value. I don't have any information to suggest otherwise, so I'm going to go with 380 liters per day as the hot water consumption in the base case. I'm going to measure the hot water temperature at 60 degrees C and input that here. I'm going to use the formula to determine the incoming water temperature of the building based on seasonal variations from 1 degree C to 11.5 degrees C. If you know your water temperature is fixed, you could pick user defined and set that value there. For most purposes, the formula works very well. We're going to assume the water consumption could be any time during the day, i.e. 24 hours a day. If we did change the hours per day, it will ratio the consumption downwards. So basically, this will ensure that we're still using 3.8 liters per day per person. In the base case, we have no heat recovery, so I'm going to go ahead and hit 0 there. Under the heating system, RedScreen has already selected the fact that there's a hot water heater here and that I've input that earlier. If I had multiple heating systems in here, I would see other ones and I would have to pick the hot water heater from that. At this point, I have established my base case, 8,627 kilowatt hours of energy in the base case. I will now use copy base to propose to populate the proposed case identically. And one more step will give me the answer I'm after. That is, how much energy can I save using flow restricting faucets or aerators or devices that reduce the water at the faucet. I'm going to assume that I can cut the water consumption in half because the ones in my building are fairly old, and I'm going to use then a number of 190 liters as the total consumption. At this point, RedScreen has calculated that I'm going to save, as you could probably guess, 50% of the energy, 4,314 kilowatt hours of electricity. And I'm going to enter the fact that it's going to cost me about $600 to change all the devices in my facility. And I will then go to my include measure screen to take a look at the payback. As we can see, faucet aerators or flow restriction of this type is a pretty good investment with a 1.4 year simple payback.